with constructive interference. Okay, so for constructive interference, you have two waves that are identical. You got, well, wave packets, wave crests here. So you got two crests that are traveling towards each other. And we'll label one as A and one as B. We'll make the one on the left A, and we'll make the one on the right B. Okay, so that's what they're doing before. And let's go ahead and give them values. Let's go ahead and say A has a value of 5, and B also has a value of 5. When they meet in the middle, something interesting is going to happen. You're going to have your wave A, but you're also going to have wave B. So the waves overlap each other. When they overlap each other, they're going to combine their values. So A is 5 and B is 5, which means we're going to have a value of 10. So what we're actually going to see is this big wave that happens. And that's because the energies combine. It's called superposition is the name of this thing. But we just call it constructive interference. And that's what's going on. You're combining the two waves. You're combining the two waves together to see what you get. And then afterwards, they go back to doing what they were doing before, like nothing ever happened. Okay? But this time, A has passed through, and so has B. And you get something like that. So that's constructive interference. Notice the waves did not bounce off. They just traveled through each other. So they just traveled through each other. And that gives you what's going on. What are you looking for, Dursa? So keep lab B. Staple it's lab A to your paper. Yeah, hold on to lab B because that's what we're talking about now. So there's constructive interference. So destructive interference works the exact same way. The difference is lab A or wave A is up and wave B is down. So here's A, here's B. Okay, they're traveling towards each other. And let's again assume A has a value of 5, but now B's got a value of -5. So now you've got the same thing kind of going on. You've got A doing something like this, but B is going in the opposite direction. So it's not A plus B this time, it's A minus B this time. So A plus a -5, or you can think of it as 5 minus 5. So what you're going to end up with is 0, which means it's going to be flat. And that's how noise-canceling headphones work. So noise-canceling headphones work by having two different waves going in opposite directions, or opposite positions, and they cancel each other out. So literally, the wave goes away for a second, but then they continue on from there. So it looks like they bounce off, but their energy, they're not a physical thing, so they don't actually bounce off, they actually pass through. So here's A, and here's B. So that's what you get for constructive interference. Or sorry, destructive interference. All right, last thing I want to look at is standing waves, because it's not clear why they work the way they do. All right, standing waves. They work like this. You have two waves that are traveling. So you got wave A that looks something like this as you make the wave pulses down. And wave B that looks like this, except wave A is going to the right down the slinky, and wave B is going down the left. So what happens is those waves overlap each other. And because they overlap each other, they're going to do constructive interference, which means you're going to get a monster large wave, then a monster small wave, monster large, monster small. I'm not drawing these that well, and so on and so forth. So you're going to get those large loops. Then they're going to travel a little bit further. Okay, so here's the second one. And the same thing for B. B's gone a little further also. So now, where you have a positive A, you have a negative B. So they're going to cancel each other out. And then they'll go back and keep going a little further. So if it goes a little further again, and the orange one goes a little further again, they're going to make super wave again, but in the opposite directions. Okay? So that's why it looks like it flip-flops back and forth. It flip-flops back and forth because it does constructive interference, then destructive interference, then constructive in the other side, then destructive, then constructive on the first side, then destructive, and so on and so forth. And so that's what you're seeing. You're seeing that combined thing. So what you want to make sure you understand is the two different types, constructive and destructive, and how that affects standing waves. That basically standing waves are just continuous constructive and destructive interference. That's why you had to get the right frequency, because if you got the wrong frequency, they didn't really do anything. Okay? They just kind of hung out from there. All right. So here's what I want y'all to finish up with.